welcome back for part 2 of the video about categorical variables. The next type of graph we're going to look at is a pie chart, and that's just another common display that shows a whole group that's broken down into several categories. It shows the whole group of cases as a circle. Pie charts give us a quick impression of how a whole group is partitioned into smaller groups. The slices are going to have to be proportional to the fraction of the whole in category. So here we have a pie chart that summarizes the genres of 1,300 movies released between 2006 and 2018. Okay. First of all, is this an appropriate display for the genres? So I'd like you to pause the video and try answering questions A through C, and then unpause when you're ready to go over it. The answer is that yes, this is an appropriate display for the genres because we have genre, which is a categorical variable. So we have categories here, and pie charts are a way to display those categorical variables. Okay. By looking at this, which category looks like it was the least common? And if you look, it appears that white little sliver there is documentaries. So those would be the least popular type of genre. We also need to write a few sentences describing the pie chart. So what you want to do is you want to pick out features that stand out to you. Like we already know that documentaries are the least common, right? What's the most common? So if I look at this, it appears that action, which is the blue kind of slice there, that is the most popular. So that's something I'd want to mention. So comedy. So that's comedy actually, right? Comedy, not action. Action is here. So comedy appears to be the most popular genre. While concerts, musicals, and documentaries maybe were the least popular, right? So the smallest slivers there would be the whites, which we talked about, documentaries, and then concert musicals. Okay, so that's something in contrast here. Comedy is the most popular genre, while documentaries, concerts, and musicals are the least popular genre. Okay, let's go back to looking at some Titanic information. Earlier we looked at some graphs which talked about the crew and then the first, second, and third class, and we looked at how we wanted to make sure we didn't violate the area principle. So here's actually the information broken down. We said that in that graph it appeared that the Titanic was made up of mostly crew members, right? But as you can see, it only makes up 40% of the overall. The other 60% are the first, second, and third classes. Okay, but the graph did not show that. I don't know if you're all familiar with some facts about the Titanic, but only 32% of those aboard the Titanic survived. So 68% of the people on there perished, and there were a lot of reasons for that. Was the survival rate the same for men and women? Maybe that's a thought we might have. Or how about for children and adults? Did more children get saved? Because typically it's women and children in lifeboats first. How about for all ticket classes? So to answer this question, we'd want to look a little bit more at the data, and we can arrange the data the counts for two categorical variables. So we want to look at survival and class because I want to look a little bit more closely at this. So we have our columns, right? And we have our rows. So our columns would be there. And then our rows are here. Okay. And we basically want to know, like, what do the columns represent? When I'm looking at the columns, what am I actually looking at? So these numbers here show me how many people were saved and how many people were lost. So that's what each of the columns represent. And that's contingent upon the class. So here we can see that there were 203 first class members saved and 122 first class members that died. As opposed to, if you look at the crew, there were 212 saved, but there were 673 of the crew that actually perished. Okay, so this is contingent upon the class. Okay, so what do the rows show? The rows show how many were in each of the classes contingent upon their survival status, right? So here we have 711 that were saved, and each of the numbers in the class, and then how many died in each number in that class, right? So here we have the number that were in each ticket class, and contingent upon their survival status. And we call this table, unsurprisingly, a contingency table. The margins of the contingency table, the frequency distribution of one of the variables, is called its marginal distribution. Okay, so here we have the marginal distribution of survival, and here we have the marginal distribution of the classes. Okay, it's just the numbers in the margins. So here we have that same exact table now broken down even more. Okay, here we have our original row of number of first class, second, third, and crew that were saved, and then number lost. But what we've did is we've broken this down into percentages. So the percent of row, the percent of column, and the percent of the table. So in other words, here we have 203 divided by 711, and that gives us 28.6%. And then here we have the percent of the column, right? So it's 203 divided by the total count in that column, 325, which gives us 62.5%. And here we have percent of the tables, that's 203 divided by 2201, which gives us 9.2%. Okay, so what does that tell me? This tells me that 28.6% of the saved individuals were first class. And here this tells me that of all the first class people, 62.5% were saved. And then this tells me that first class made up 9.2% of everyone on board. Okay, that were saved. Okay. So here we see the percentages for each combination of class and survival. And for each count, there's 3 choices for the percentage, as we went over, okay? The percentages tell us what fraction of all passengers belong to each combination of column and row category. All right, let's look at another contingency table and answer some questions here. You can pause the video to read it and then unpause. A recent Gallup poll asked 1,008 Americans age 18 and over whether they plan to watch the upcoming Super Bowl. The pollster also asked those who plan to watch whether they were looking forward more to seeing the football game or the commercials. The results are summarized in the table. What is the marginal distribution of the responses? Okay, so marginal distribution is just the numbers in the margins, all right? So what I want to do here is I want to figure out the marginal distribution of each of the responses. So I'm going to take the games and look at the margin, which would be 479. And I apologize, my marker is not working properly. So I have 479 people that were interested in watching the game out of the 1,008 that were surveyed. And if I divide 479 by 1,008, I get 0.475, so I want to multiply that by 100 to change it to a percentage. So about 47.5%. Okay, what does that mean? It means that according to this poll, about 47.5% of American adults were looking forward to watching the Super Bowl game, okay? As opposed to the other ones, which would be the commercials. And that would be 237 over 1,008. Okay, which comes out to 23.5%. And then won't watch would be 292 divided by 1,008, which comes out to about 29%. So if I was to summarize this, I could say something like, according to the poll, 47.5% of American adults were looking forward to watching the Super Bowl. (23.5%) were interested in watching the commercials, and so on. 29% won't watch at all. So remember that theme of earlier when we said think, show, tell, right? So think about what it is I need to find. We want to show, so that would be our contingency table, and then tell. So talk about what you actually found. Okay. Let's say we would like to look at this a different way. We want to look at whether the chance of surviving the Titanic sinking depended on ticket class. One way is to look at how the distribution of ticket class changes between the survivors and the non-survivors. Okay? To do this, we're going to look at the row percentages. And by doing this, we can now see the what's called conditional distribution. So when I say conditional distribution, what I'm referring to are these different percentages here. Those are the conditions. So it's the class based on whether they were saved or lost. Basically, conditional distributions show the distribution on one variable for a subgroup of individuals that satisfy a condition on the other variable. So here, the two conditions are first class and saved, and then this is first class and lost. We can look at a bar chart or bar plot. Here we have a relative bar chart, right? Because I've got percentages. And this is ticket class distribution by survival status. If I take the bars and I stack them in order, right? I have a Pareto chart basically. Now we can see that the group that had the largest amount of people that perished were the crew. We can also see that roughly, the same percentage of first class was saved as were the crew. Okay, but the crew overall had a larger percentage that were lost. We can take these two bar charts and we can stack them, and we have something now called a segmented bar chart, which is a great way to display data that you're trying to compare that's categorical. So ticket class versus survival status. And all we're doing is we're taking each of the percentages and we're stacking them. And we've got two bars. We've got saved and lost. Okay. And all we do is we take like the first class, which would be about 28% maybe. And that's what this green part represents. And then here, this is about 15% maybe. And then here we have about 25%. And then the leftover here, which is about 30%, okay, as you can see. And then we did the same thing here. So what's nice about it is you can look and go, oh, basically the same percentage of crew was saved as first class, but a smaller percentage of first class died compared to a much larger percentage of the crew that died. All right, feel free to pause the video again, and this time you're going to look back at the Super Bowl data, and I'd like you to construct a graph that makes it easy to contrast the gender distribution across the three response groups, and then describe how the distributions differ. Okay, and you can feel free to pause your video, and then unpause it when you're ready to go over this. Okay, so I'm going to take my data, and I'm going to copy and paste it so we can look at it. And my iPad's not letting me do that. Give me 1 second. There we go. Okay, so I want to copy that and then put it down here so we can take a look at it. Okay. So here we can see, again, the responses based on the sex, okay? And we're going to make a graph. So since it's categories, right, we have categorical variables, response and sex, we can make bar charts, we can make pie charts, or this might be a good time to do a segmented bar chart. So let's break these down, okay? I want to look at the contrast between gender distribution across the different response groups. So I just have males and females here. And I have the games, commercials, and then we'll just call it W for won't watch. So if I want to break this down according to sex and response, I know 279 males out of 492 are going to be watching the game. So I want to convert that to a decimal and then a percentage. And you already know how to do that. You get about 56.7%. We're going to do that for each of the different responses. So 81 out of 492. And that gives me 16.5%. And then 132 out of 492. And that gives me about 26.8%. Okay, and I'm going to do the same thing for females. So for females, this time I'm looking in this column, and it's 200 out of 516 prefer to watch the game. And when you divide, you get 38.8%, and so on. Okay, so now, shrink this down a little bit. It's easy to create your segmented bar chart. Okay, so all I need to do, again, you would need a title, okay, and I need a vertical and horizontal axis, and here we're just breaking it down into males and females. Okay, so let me move this down a little bit so I can add a title in there. So our title here, we can call it maybe gender distribution of Super Bowl responses. Okay, and here we have the percentages on the vertical axis, right? So I always want to go up to 100%. So maybe I'll just count by like 25%. 50, 75, 100. And you don't need to label every single increment. Again, try to make those as evenly spaced as possible. And then in the bottom, we have our sex, and we've got the males and the females. Okay, and you can do this however you want, but the important thing to remember is it needs to add up to 100%. So I'm going to make my whole bar go up to 100%, and then I'm just going to divide it up. Okay, I don't know why it just did that. Okay, and then I'm going to do the same thing here. All right, so now I'm just going to section everything off, okay? So I'm going to start with the game, which is about 56.7%. So I know that this is about 50, right? And that's 75. So you figure like, it's going to be about maybe 56.7% would be like right about there. And then from there, I'm going to add 16.5 on, right? So if that's 56.7, if I add 16.5 to that, that's going to take me to like 73.2. So I know I'm just going to come right before that 75 there. And then there's your three sections. So you have right here, you've got the Super Bowl, and then you've got those who will watch the commercials, and then those who won't watch, right? So we're going to make a little key. Won't watch, commercials, and Super Bowl. Okay, so here's our key. Won't watch the commercials and the Super Bowl. Okay. We're going to do the same thing for the females. So that's 38.8%. So here's 25, 38.8, maybe right about there. And then I'm going to add 38.8 plus 30.2. So that takes me to about 69. So if this is 50, that's 75. 69 is going to be like right about there. And then you've got 31, which should be a little bit bigger, right, than the 30.2. So now I'm just going to color it all in. And then there you go. And this gives us a nice visual of what this table is showing us. So we can see a larger proportion of men are going to be watching the game as opposed to females, right? But more females are interested in looking at the commercials than the men. Okay, that is the end of this video. Please join me for part 3 of chapter 2, where we'll be discussing association and independence. Have a great day, everyone.